Hi and welcome to the session. In this session, we are going to discuss about UV visible spectra and applications of UV visible spectroscopy from Unit 5 Spectroscopic Techniques. So, what is UV spectra? UV spectra is the graphical representation of a data obtained by the UV visible spectrophotometer. UV visible spectrophotometer on analysis of an analyte solution gives the data in the form of UV visible spectra or UV visible spectral data that can be converted in the spectra. Here, the absorption of UV visible light leads to excitation of electrons from bonding molecular orbital to anti-bonding molecular orbital. This absorption depends on the structure of analyte. The UV visible spectra for isoprene unit is shown as follows. This is the UV visible spectra of the isoprene, in which x-axis belongs to the wavelength in nanometer, while y-axis will belongs to the absorbance or percent transmittance. Now this graph of absorbance versus wavelength or percent transmittance versus wavelength in nanometer is a characteristic graph for that isoprene unit. So this UV visible spectra gives us two important information. First is the lambda max, that is the characteristic wavelength at which maximum absorption will be observed in specific molecule. So for isoprene, lambda max is 222 nanometer, which will be the unique value for that isoprene unit. The graph represented here is taken from the source that is mentioned below. The UV visible spectra is a graph of absorbance or percent transmittance on y-axis and wavelength on x-axis. It gives information about lambda max. It is the wavelength at which maximum absorbance is observed. It is a characteristic property of an analyte and depends on the structure of that analyte. Now we will discuss about the applications of UV visible spectroscopy. First application is the structural information. As we have discussed in the previous slide that we get the lambda max from the UV visible spectra. That lambda max is the characteristic property of a molecule due to the presence of chromophore along with the oxochrome. By knowing this value, structural information of that molecule can be extracted. Then second is the qualitative analysis. UV visible spectra of an unknown sample can be matched with the spectra of known compound to analyze the sample qualitatively. So if you have the standard spectra of different molecule, you can check out that standard spectra, you can match that standard spectra for the known molecule with the UV visible spectra obtained for the specific sample, and you can find out the molecule which is there in the sample. Then chemical kinetics. According to Beer's law, absorbance is proportional to the concentration. Hence, during the chemical reaction, absorption intensity of a reactant decreases while that of product increases, which will help to study the chemical kinetics. Then detection of impurity. Any change in the spectra of a specific compound will indicate the presence of impurity. So if you have got the standard sample and with that you have got the UV visible spectra of that standard pure compound, then you can check the UV visible spectra of the sample and if any deviation is there in that spectra, that will indicate the presence of impurity. Then qualitative analysis. By use of UV visible spectroscopy, solution of unknown concentration containing specific compound can be evaluated. Here, the same analyte solution is prepared with different known concentration, and its absorption is determined. Now a graph is plotted with absorption versus concentration, which should give a straight line as per the Beer's law. Now absorption of a solution containing unknown concentration is evaluated, and by using graph we will be able to find out the concentration of that compound in the solution. So here we will take the standard sample and we will make the solution of different concentration of that sample standard molecule. Then we will check out the absorbance of that solution at different concentration. We will plot a graph. So such kind of graph will be obtained. Now we will check the absorption of that unknown solution. Suppose the absorption of that unknown solution lies here on the y-axis. We can check out the corresponding value of the concentration. So these are the applications of UV visible spectroscopy. Thank you.